Okay, 3.2 is called linear functions. All right, so graphs of linear functions, they're going to form a non-vertical straight line. Okay, so it's pretty easy to identify them if you're looking at a picture. And you can have an equation for a vertical line. It just wouldn't be a function because it would fail the vertical line test. But looking at these, hey, this is appears to be a straight line, so I'd say yes, this represents a linear function. Same with this one, that's also a straight line. The other two have curves, so this is a parabola, it's not a straight line. That will be a no, and this will also be a no because of the curves. Okay. All right. So linear functions are going to have a constant rate of change. Okay, and that means that the input values, if they're changing at a particular rate, the y's also change at a particular rate. That's a little bit of a weird definition there, but it's easier for me to show you with an example. Okay, so using this definition, we're going to decide if this table of xy values is going to represent a linear function. So in other words, if I graph these points, would a straight line fit through them? Okay, and one way to check is to look at the differences between the x's. So if I look at the x's, I can see, okay, getting from one x value to the next, I'm thinking, what am I doing? Am I adding or subtracting something? Well, these are getting bigger, so I'm adding. 2 plus 3 would be 5, right? If I take 5 and add 3, I get 8. If I take 8 and add 3, I get 11. So that means that the x's are changing at a particular rate, right? I'm adding 3 to get from x to x. It doesn't have to be counting by 3s. It could be counting by 1s or 2s or 10s, or it could even be going down. I could be subtracting 3 from x to x. But I've got a constant rate for my x's, and now I want to see if I also have a constant rate for my y's. It doesn't have to be adding 3s again. I just want to get the same thing out for all of the y's as well. And then I'm thinking 4 plus what is 6? That would be 2. 6 plus 2 is 8. These are counting by 2s, right? So my answer here is going to be yes. The x's are changing at a particular rate, and so are the y's. So when both the x's and the y's are doing that, then I know a straight line would fit these ordered pairs. So my answer here is going to be well, it's not a question, actually. It says this represents a linear function. But that's the kind of test I'm going to do, okay? So let's try that on these next examples. So let's see. I've got, looking at this one, thinking how am I getting from 4 to 7 to 10 to 13? Well, I'm going to be adding 3 for all of those. Okay, so I've got a steady rate for my x's. Now I want to see if I have a steady rate for the y's. Now these are getting smaller as I go from left to right. So 14 to 12, I'd have to subtract 2. 12 to 10, subtract 2, subtract 2. So I have a steady rate for my y's as well. So I can say that, yes, I do have a constant rate of change here. That means, yes, this is going to represent a linear function. Okay. Part B, let's try this out. So I can see for my x's, it's going down, so it's going down by 5s, right? I'm subtracting 5 to get from x to x. Looking at the y's, I'm going to be adding 4. This is called a difference because you could take any number like the 11 and subtract the previous number from it, and that would give you 4, right? Because if I'm going that way, I'd have to do the subtraction, but this way then will be addition. So since 11 minus 7 is 4, that's what I get, okay? And then 15 minus 11 would be 4, so that has a difference of 4. 19 and 15, if I subtract, I get 4 again. So again, I got a steady rate of change for the x's and for the y's. That means I have a constant rate of change for the whole set of points, and that means a linear function would fit that, okay? All right, next one. Let's try this out. So I can see those x's, we're counting by 3s. It's going up by 3. For the y's, let's see, we're adding 1, then 2 to 4, we'd have to add 2, and 4 to 8, we'd have to add 4. So you could think of it as multiplying by 2, but we're only talking about addition and subtraction when we're looking to see if this a linear function fits like this. So this is not going to be a linear function because I don't have a steady rate of change for the y's, so this is going to be a no. Since the x's are lined up like that, but the y's don't work like that, that means it's not going to fit a straight line. In an emergency on a test or something, you could just plot the points and see if it looks like a straight line will fit them, and I think you'll find this is going to have a curve, look like it's curving upwards. It's actually an exponential function. All right, so next page, we've got equations of linear functions. Equations of linear functions. It's any equation that can be written in this form, y equals mx plus b, is going to be a linear equation, okay? So the m and the b are going to be numbers, okay? It's going to be the slope and the y-intercept, but we're not getting into that part yet. But it might be, you know, y equals 2x plus 3 would be a linear function, or y equals 3x plus 4, something like that. So the m and the b can be any numbers, okay? So I've got a big list of different equations here. I'm going to decide which ones are linear functions. So, hey, this would be the m, this would be the b. So that one fits the bill there. So this is going to be, I'm just going to circle the ones that are linear functions, and I'll cross out the ones that aren't. So this is a linear function, okay? This one's a little tricky because it seems like I do have x over something, but I want to think if I could write it in this form. So if I did 1/5 times x plus 2, well, if I did 1/5 times x, that's the same as x over 5, right? Because I could think of this as 1x over 5. So then you could think of the x as x over 1, multiply straight across, that would give you x over 5. So this is going to actually be a yes, okay? And so looking at that, you might think, okay, well, c is going to be a yes as well because I got a fraction there again. But this one, you can't actually split it up like that, because when I have it written like this, you do the x times the numerator because it's x over 1. So this one, I can't write it as something times x in that middle part. It's 3 over x, but it's not something times x, it's something divided by x, okay? D seems like it's missing the b part, but hey, there it is. If it's missing the b part, you can just add in a plus 0, and that would still count. So this one is going to be a yes. That is a function, okay? All right, I don't have something times x because I can't, square root is different than multiplying by x. So that one does not work, okay? It's okay to have a square, if I had like square root of 5 at the end, that's fine, but you can't have the x part be in the square root because you're not going to be able to write it in that format, okay? And next one, this has the that third power, and it doesn't have, the x isn't raised to the third power in the formula, so I can't write this as something times x to the first plus something else. That one's not going to work either because of that 3, okay? All right, this one doesn't look like it's the right format, but let's think what would happen if we wrote this without parentheses. I'd have to distribute the 4, and I'm going to get 4x, 4 times negative 1 is negative 4. And now it is in the right format, so this one works, okay? And this one, again, I've got something times x plus something else. It doesn't matter if it's a decimal, that's okay. The m can be a decimal or a fraction or whatever, so that one works as well. Okay, so the ones I circled are all functions, are all linear functions, I should say. Okay, all right. Next up, we're going to talk about discrete domain versus continuous domain. All right, so just looking at these pictures, hopefully you can see pretty clearly the difference. So with discrete domain, it's going to consist of only certain numbers within an interval. So I've got numbers. If I'm domain, remember domain, we're talking about the x's, right? For a domain, range would be the y's. But when I'm looking at my x values would be 0, 1, 2, 3, 4, 5, 0 through 5, right? So it's integers from 0 to 5, but it's not everything from 0 to 5. 1.3 or 2.8 isn't in there. It's just 0, 1, 2, 3, 4, and 5. So that's what integers are, right? They're nice round numbers like that. So that's what a discrete domain is, as opposed to a continuous domain. This is still going to be numbers from 0 to 5 if you're thinking about the x's. It goes from, if you're looking at the domain, it's how far left and right it goes from 0 to 5, right? So both of these do that. They go from 0 to 5. But this is different because it's everything from 0 to 5. So all of the decimals, any point between 0 and 5 on the number line, including 0 and 5 themselves, would work here. Okay, so hopefully that is clear, the difference between discrete and continuous. Continuous, the line continues. It's everything in that interval. Discrete's just those particular places. Okay? All right, that's it for this section. See you next time.